A number real soon. Is it there? Hello? Oh, yep, it's recording. Okay. Okay, so today we are doing 9.3. 9.3. Can you see that? I don't like that marker at all. Great markers. See if you can see this. Okay, the title is Trig Functions. This one's better. Of general angles. Okay, so the first thing we have to do is we have to talk about what a general angle is and all the little pieces to it. So we're just going to draw the 4 coordinates. Just real lightly. Doesn't have to be real big. Okay, just like before, we have an initial side, right? It always is just our starting point, or x-axis is positive. And then we have a terminating side, right? We just draw that anywhere. So today, I'm just going to draw that in the 3rd quadrant over there. Now, to know where our angle is, they draw an arc, right? We see that it goes from one place to another. You go, oh, okay, this is the side our angle is. You need to know which side it is. So wherever that angle is, that's the measurement of our angle, and we represent it with the sine of theta, remember, which is 0. And you can just put a straight line through it instead of trying to draw the squiggly line through it, because I know when you write fast, it kind of is a pain in the butt. Okay, so now theta, little side mark, theta is always an angle in standard position. Now, the important thing about standard position is it has to be positive. So everything we do from now on has to be positive. So they give you a negative angle, we're going to have to change it so it is positive, which is why you had to learn what coterminal angles were, so you could change it by adding 360 so that it would change to be a positive angle. Okay, now on a coordinate grid, we always have a point. We represent it with the letter P, and all points have x comma y, right? That's nothing new. And that's just a point on our terminal line. They'll always give us this information. Lastly, I'm going to put an R here. That's on that line right there. What does R stand for? R is radius. Okay, if we don't know what R is, what is the theorem we already talked about that helps us find R? Talked about it. You talk about it in geometry. We talked about it in 9.1 or 9.2. Starts with a P. Yeah. Pythagorean. Okay, now Pythagorean theorem, you're used to a squared plus b squared equals c squared. Now we're going to write it a little differently so that R is by itself. Okay, so the Pythagorean theorem is going to be R equals, because we're never going to know what R is, we're going to have to figure it out, the square root of x squared plus y squared. That is the Pythagorean theorem. It's just rewritten so R is already by itself. Normally this is R squared equals x squared plus y squared. Okay, so it's the same thing. It's just rewritten in the simplest form. Okay, now from there, we can find our 6 trig function. Oh, I'm missing something. We need to put a little dashed line from the point straight down or up, depending on where you start, to the x-axis. Okay, because look, this is a little triangle. That's going to help us see why we're using the Pythagorean theorem. Okay, this is going to help us find the 6 trig functions. So what are the first 3 main trig functions? Sine of theta, cosine of theta, and tangent of theta. Okay, you already learned this. What does sine of theta represent when you have a triangle? Yep, in this case, your theta here is like this little guy right here. That's your angle, technically. Sine of theta is actually y over r, which is the same thing as opposite over hypotenuse. It's the same exact thing. You can still see that bright? Okay, good, because my computer went dark. Okay. Cosine is x over r. And then, can you guess what tangent's going to be? Correct, it is y over x. And then we have three other trig functions that are basically the inverses of these three trig functions. What are they? CSC, which is called cosecant, then secant, then cotangent. Cotangent. Oh, it's an O. Cotangent. This is an A with tan, but this is an O with co. Okay, cosecant, what's its fraction going to be? R over y. What is secant's going to be? R over x. And what is cotangent going to be? X over y. We already had y over x. Okay, so we're going to use this information. I'm going to grab a different board so I don't have to erase right away. And we are going to solve a problem. Okay, so it says the terminal side theta contains the point, and this is your point, -3, -4, period. Find the 6 trig functions. Okay, so just want a rough picture because you need to have all the information. What quadrant is -3, -4 in? Third quadrant, so it's kind of like where we were. So if we had a little triangle there, -3 is your x value, -4 is your y value, theta is your theta. What do we not know? R. Can we use our x and our y to find r? Okay, r equals the square root of x squared. What is x squared? 9 plus 16. What's 9 plus 16? What's the square root of 25? 5. So I would have the picture. The pictures help a lot. So then, can you make your 6 trig functions? Okay. Which ones do you always make first? Our 3 main, and then you just have to make their opposites. That's ugly. Okay. The theta sign will always be in the corner closest to the origin. Always. Technically, it goes all the way around, but it's always in the corner closest to the origin. It's in that little point. It's all in this spot right here. Every single time. When it's on a coordinate grid, yes, that is actually a good question. You're welcome. Well, on my computer, you can always ask me questions. You just didn't. So, sine, what is sine going to be? Cosine? I'm a little weird on my sizes. Next. It'll be -4 over -3, which is positive 4/3. Right? 2 negatives make a positive. And then cosecant. I would just keep the negative with the 4. It's okay. When in doubt, put the negative in front, not up with the 5. So put that guy out there in front. I just don't have enough room. Secant. And then cotangent. Pretty easy. Doable. Okay. Okay, that's part 1. We're 1/4 of the way done. Woohoo. Okay, next. A little thing to say. If the terminal side of an angle in standard position, right, which means it's still positive, lies on the x or y axis, so it's not in between the coordinates, it's actually on, like the lines between them, it's something different. It is called a specific thing. It is called it's a weird word, it's called a quadrantal angle. It's spelled exactly how it sounds, quadrantal. So quadrantal angle, right, again, the terminal side of an angle lies on the x or y axis. I wrote x twice. That means it's going to have specific things going on. I wish I could zoom out, but I can't. Oh, wait. I forgot I have this ability. Magic. Okay, so now I'm going to show you the 4 different spots that line could be and how you find them. Okay? First, if theta is 0 degrees, do you remember what 0 degree, if it's in 0 degrees, you remember what that is for radians? This is part of your unit circle, huh? I know 360 is too far. Correct, Luke. 0 radians. 0 degrees is also 0 radians. This is what, I'll grab a new marker. This is what the picture looks like. This is what the picture looks like. That means the line is literally where it starts. Obviously, it doesn't move. So theta just stays right there. Your point, they would use, like, you know how what we just did, they give you a point on the terminal side. Your point would be r comma 0. How normally it's x comma y. So you see how r is in there? So now your radius is already given to you somehow. So you don't have to find it. Okay, so whatever x is in this case, r is also it. Okay, now the next one, if theta is 90 degrees, what's the radians? Think about it. That means it's right there. I just draw the picture for you so you can think about it. We're gonna write radians right here. I wish you knew because this is gonna be important. That's, you're ahead of yourself by a couple sections. It is pi over 2. It is half pi. The point for this is 0 comma r. Just like on the y-axis, a y-intercept is 0 comma the number, right? These points should make good sense. And obviously your theta is over here. It's the distance from there to there. Hey. Next, theta at 180 degrees. Remember, this is a radian. Correct. It is pi radians. It's actually 1 radian. It's radian, not radians. Oh, that's ugly. It's fine. So that means it's the x-axis, right? So it goes from one spot to another. So theta is there. Your point is going to be what? What do you think your point's going to be? Close. Negative r comma 0, because it's on your negative part of the x-axis. Nice try. Okay. One more. When theta is 270 degrees, Lincoln, it is 3 pi over 2 radians. That means we start here. Oh, I'm killing my orange marker. All the way around. That's our big angle, or radians. Point down there, what's that point going to be? 0 comma negative r, correct. We did not do the last big degree. What's the last big degree? 360. What's the radians for 360? 2 pi. The picture, though, looks exactly the same as which one? 0, right? Picture looks exactly the same. Okay, so now we're going to do that. It's just like what we already learned. We're just now doing the terminal sides. We're going to do the same thing we just did, still finding the 6 trig functions. Okay? Now, this one says the terminal side, and always gives you theta, in standard position contains the point -2 comma 0. Find the 6 trig functions. So it helps to see the picture because we're going to need the pictures later. Where is -2 comma 0? It's on 180, right? Right? So that means x is -2. What's y? 0. What's our radius? Close. It's just 2. Because it says -r, your radius can only ever be a positive number because it's a length, it's a distance. So radius is 2. Luke, you are on fire today. I'm proud of you. Okay, so now using these, just like we did before, if you want, even though it doesn't make a triangle, you can always make one and find the 6 trig functions. I just don't know if I have enough room. Barely had enough room. After this, we'll be halfway through. Yes. Okay. We did not switch in the x and the radius. The radius is in the spot. It's r. It says -r. Look at this one. It says a 0 comma -r. So you see how the negative sign is separate from the r. So the r is a number, and the negative sign is applied afterwards. So the r is is just the positive number. So a radius, because it's like a distance from one point to another, because it's always the hypotenuse, it can never be negative. It's never negative. These ones are going to be funky because you're going to have zeros in them, right? So you may have words in here. Something over 0, right? Makes a word. Yeah. No, because that makes 0. Yes. See if I can put the picture over here. Oops. Because my computer went completely sleepy. Okay. My bad, guys. Did you figure them out yet? I'm going to erase another board while you guys do that. See if you can do them. Oh, I should have gave them their own papers. Try them, draw the picture. If not, always just draw a triangle. I'm not lying to you. It does not matter. Draw a triangle. Always pick theta in the same spot as long as it's not like 180. And then just do the hypotenuse the same number. And you can always just draw a random standard right triangle, label the sides. As long as your opposite and hypotenuse are right, you're fine. I know 180 is the hardest one because it literally can't make a triangle because it's a line. No. Which is why you have that beginning part that says sine is y over r and cosine is x over r. All right, so sine is 0 over 2. So this is the answers I got. Those are the answers I received in simplest form. Because sine, right? Because sine is y over r, so it's 0 over 2. 0 divided by anything is 0. Cosine is x over r, negative 2 divided by positive 2. Well, that's negative 1. Tangent is really sine divided by cosine. Well, sine is 0, cosine's 1. That's 0. And then the cool thing is if they were 0 here, they're undefined here. So because the opposite would mean 0 would be on the bottom. And then the opposite of negative 1 is still negative 1. Does that make sense? Don't skip the steps, right? Make sure you show your fractions so you can see where it's coming from. That is halfway. Okay, next we are going to talk about reference angles. This one has like a tiny bit of math in it, basic subtraction. Okay. Oh, I have to even flip the page. Okay. So, a reference angle. Okay, is an acute angle formed by the terminal side and the x-axis. Okay, so I'm going to show you all 4 quadrants and what they mean. Okay, so quadrant 1. Remember, quadrants are technically numbered in Roman numerals, if you didn't remember. Okay, so I'm just going to draw a little quadrant 1. Okay, so if we just had a little angle, remember acute angle means what? What is an acute angle? Can you give me your own general definition of what an acute angle is? Less than 90 degrees, right? And 90 degrees is that other axis, right? So it just has to be somewhere in here. So I'm just going to say, hey, theta's in there. The cool thing about this one is it's given to you. Whatever theta is, that's our original angle. Our reference angle is the same exact thing. We denote the reference angle with a prime number, like like factor prime number. So that guy right there, that does mean reference angle. Okay, I hope you remember that angle sign right there coming back to you. So if it's in the first quadrant, whatever angle you have, as long as it's positive, because it has to be in standard form, you're good. Okay, that's the easy one. Now, quadrant 2. This one, we're going to draw just the second quadrant. A little bit of the first. Okay, now we're starting all the way from over here, starting the first quadrant, and we're going to end somewhere in the second quadrant. So original angle is that big guy. We want to find the reference angle. The reference angle is the distance from the terminal side to the x-axis every single time. It's always acute. Okay? I'm going to show you degrees and radians. Your reference angle in degrees is you take 180 degrees and subtract whatever theta is. That'll find you what your reference angle is. As long as it's less than 180, you're solid. Now, in radians, what does 180 again represent in radians? Pi. So you can do pi minus theta. Always do equals. So no matter which form it's in, you can find that reference angle. Okay? Next. Quadrant 3. Okay, you're going to have a bit of all 3 quadrants. Okay, again, quadrant 3, it starts all the way at the beginning because it's positive and ends there. Our original theta. Where's our reference angle? Again, it's from our terminal line to our x-axis. If I start here, where am I going to go? Up. Our reference angle is this much. So we're kind of going back. We're backtracking in this one. So for this one, our reference angle is theta minus 180 because the theta is now bigger than it. Bless you. Bless you again. Or theta minus pi. We have to be really good at this. If we cannot do reference angles, we literally cannot do anything we're going to learn for the rest of the semester. Okay? And then quad 4. If you didn't know what 4 was in Roman numerals, there it is. Again, all the way around. That's your theta. Your reference angle is just this little guy right there. It's what's left over. I know it's hard, so I'm on a little board. What are we going to do here if we're getting to finish our circle? we always subtract. What are we gonna subtract? Yep, 360 minus theta. Because you're only going to the x-axis. So you only use the numbers that are on the x-axis. So we've only ever used 180 and 360. If you notice, we never used 90. See, like this one only had 180 on it. Also, we've never used 90 because we only use the degrees on the x-axis. Yep. So what is my radians subtraction going to be? 2 pi minus theta. Correct. Ooh, drop a marker. Okay. And now we are going to do a couple examples, at least one in each form. Okay, so let's start with an easy one. Start with the degrees and work our way from there. Okay, first one, 210 degrees. First thing you should do, because they will sometimes ask you to draw it, and it's just a rough guess. 210 degrees, where is that? It's in the third quadrant, so I don't really care. It's in the third quadrant. So 210 degrees is like this. That's my theta, because 210 is my theta. Now, what's the operation I am going to do to find my reference angle? Yep, since it passes the 180, you're going to do 210 minus 180. If you can't do it in your head, please use a calculator. What is 210 minus 180? 30 degrees. So as long as you put your degree sign and you put reference theta, reference angle, that's it. All you have to do is literally write this right there. Done. Is that pretty easy? Okay. The radians are harder because you have to actually think about them. Ready for a radian? Of course. I'll give you an easy one first. We'll start with a positive one and we'll do a negative one next. Okay, 2 pi over 3. So now when you think of these, you want to think about the ones you know. You know about 0, pi, and 2 pi. So is 2/3 of a pi greater than or less than a pi? It's less than a pi, so that means it's in what quadrant? If it's less than it, it's in the second one. It is. So this is my theta. We need to find our reference angle. So what are we going to do? Nope, because we're in radians, guys. Pi, which is 1 pi minus 2/3 pi. When you do radians, ignore the pi's and just go, what's 1 minus 2/3? 1/3, and then you just put the pi with it. That's your reference angle. So with the pi's, as long as they both have pi, you just ignore them and just do the basic fraction math. Okay, I'm going to give you a negative one now because that's one you have to think about. I'll just erase this one. You have to do it in radians. Okay. Next one, negative 5 pi over 4. Now, this is not your reference angle because it's negative. So the first thing you have to do is we need to get rid of the fact that this is negative. In section 9.2, I showed you how to do this. What do we add to something to find our coterminals, to find a positive answer and negative answer in radians form? 2 pi. Again, you're just really adding 2 to 5 pi over 4, which really is you're just doing 2 minus 5/4, aren't you? Yeah, so theta is actually how much? 2/4, which again, 2 pi over 4 is really 8/4. What is 8 of them minus 5 of them? Yep, so this is 3 pi over 4. That's your actual theta. What quadrant is that in? second still, because it's bigger than a half. If that's 3/4 and the whole line is 1 pi, you shouldn't even have to do the subtraction. How much is your reference angle? Remember, this whole thing is 3/4. How many fourths do you have left until you hit a whole number? 1. 1 pi over 4. Or again, you can show the work of pi minus 3 pi over 4. Either way, you still get the same answer. My important note to you with this is do not type this into your calculator with the pi's in it. If you really have a hard time with it, don't use the pi symbol. Just pull the fractions out and the numbers out from the pi and use the math that way, okay? That is my one big hint and advice to you on that one, okay? Because if not, you will really struggle. Okay, next, Jacelyn is going to come here and put her mask on. And she is going to hand you a piece of paper. Thank you, sweetie. She's going to give you this guy. Now, for those of you who did not see, I already uploaded it. I was just trying to move ahead, help myself out for this week. Now, don't just fill it out. I'm going to tell you things I want, and everything on here is not what I want, so just write your name on it. Thank you. For those of you, too, I forgot to give these to your friends who left for their state test. Will you remind them to come see me? Or if you see them, maybe someone will take the liberty to take it. This is a part of your notes, but you have the paper also. Okay, so the unit circle. First off, you have to be able to, if you look at this, hold on. Yeah, I got that zoom in action. Don't worry. Okay. So I'm only going to look at the first quadrant right now, because if you can do the first quadrant, which is what I said to Garrett earlier, then you should be able to do everything else, okay? Because you can add, hopefully. Okay, so if you notice, the inside ones have little degrees on them, except for on the straight lines. And then in between, you have these little lines. Those are for your radians. So these are your degree lines where we put our measurements for our degrees. These lines are for our radians, and we're going to ignore these order pairs for a little bit, okay? We're going to use them, and we're going to use them right now. But for your unit circle quiz, I really just want the degrees and the radians, okay? And how this works is it's the positive version. I'm going to zoom back out. Okay, and I will like white all this out so you can't see all of these points. Okay, when you take your quiz. But think about it. Starting here in the center, what's the starting degree if we haven't moved at all? 0. Out of the degrees I had you learn about, and I told you you were going to have to memorize them in your notes from last week, 9.1 and 9.2, what's the smallest degree you learned? 30 degrees. That is this guy right there. What's the next one? And also 45 is in the middle, and 45 is halfway between 0 and 90. And then what was the other big degree you learned? 60. Those are the only degrees you learned. Now, this is what you can do. Well, this is how I do this, because I can take this quiz and I can fill in all these points also in less than a minute. In less than a minute. Now, this is how I do this. I go, can you do the first quadrant? And I fill the whole first quadrant out, points and all. But you go, okay, if you can do these, then you go, okay, you can do 0, do the 30, 60, 45, do these. And then I go, okay, well, if this is 0, that's 90, that's 180, that's 270. Then from here, this is 30 above. Yes? 30 more. This line is 30 also, but it's 30 from that line. What's 30? less than 180. So 150. If this is 45, that's 90. What's 45 from that? Nope. 135. If this is 60, what's 60 away from 60? Or that's one way to do it. Another way is, how do you get from 30 to 45? How do you get from 45 to 60? So if you can do the 45s all the way around, could you just add 15 both ways every single time and call it a day? That's also an easy way. That's another way to do it. And then can you fill in all your degrees? This is like your study sheet. And you can erase these. And if you want, you can always get more blanks for me if you ask me, and you can practice and time yourself, because you will have to take this quiz, your unit circle quiz, in a minute. That's how long it is. And then we're going to continue taking our notes. It's a minute. The minute. You can know it and not be a little slower. You're only doing degrees and radians. I'm not even making you do the order of pairs. You can do it. I believe you can do it. This is my 3rd year. You just memorize it. It's a quiz. It's a quiz. Okay. Again, try it again. So whichever method works for you, either do the 45s and add 15. See if you can do these on the bottom real quick. I'm just going to give you a little bit. I'm going to pull aside real quick, and I'm going to write them and see if you can do them also. Okay? Just do the degrees. I'll write them down. Do finish the degrees. Okay. Yeah, you did. Aw. I put 2s there instead of 3s there. It happens. Good thing is I already took my minute quiz about 10 years ago. Actually, I took one. What year did I have? Whatever year I had Natalie Harrison and them in here. They didn't believe I could do it, so I took them with them and then took it. I think I finished my unit circle quiz in 45 seconds. Wow. Oh, I know. Ah. Yeah. This? Your unit circle quiz? Oh, if you get quarantined for a semester, you have to Zoom call with me. Yeah, and take everything with me. Mm-hmm. It'll be a fun time. And watch you. Make sense? Okay, radians, same thing. 0 degrees, 0 radians. What's the radians for 90? Pi over 2. I always use the line that they give you as your fraction bar, because if not, you can't see it real well. Okay, just saying, because if not, you have a hard time writing it, unless you're Hannah, because you write real small, right? 180. What's your symbol? Pi. 270. 3 pi over 2. 360. 2 pi. Okay, next one, that's the easiest one, is the 45s. These pies are all the same in the denominator. The numerators just change, right? Because you're talking about slices of pie. 45, how much of this, think about it. This is one pie. So how much is this slice? How many of them are there? 45s. 45s. $45 is pi over 4. 45 plus 45 is 90. I'm only looking at half the circle. Okay, so if this is 1/4, listen. So if this is 1/4, this is 2/4, which is pi over 2. So then what's this middle line over here going to be? No, this is 1/4. This is 2/4. So this is 3 pi over 4. This is 4/4, which is 1. 4 divided by 4 is 1. What's the next middle one? 5 pi over 4. Well, the next one is 6/4. Doesn't 6/4 reduce to 3 over 2? Yeah. Then what's the next one? 7 pi over 4. And then you get 8/4, which is 2 pi. Does that make sense? We are doing the ratings right now. Okay. Okay. Whew. These guys are opposite. 30 degrees is pi over 6. 60 degrees is pi over 3. They're opposites. How's that confusing? They're opposites. The 30 has a 6 with it. The 60 has the 3 with it. You just switch them. Also, 1/6, 2/6, 3/6, which is half. 4/6, which is 2 pi over 3. 5/6, 6/6, which is pi. 7/6, 8/6, which is 4 pi over 3. 9/6, 10/6, which is 5 pi over 3. 11/6, 12/6. Done. Wednesday morning. It's as soon as you walk in. It's the first thing you do. Okay. Then the things you need to know. I'm going to zoom in. I'm not writing it down for you. It is in your book. It is on page 614, so you can look at it later. I'll just zoom in so you can see it. Don't get your book out. Oh, that is as much as it zooms in. What if I do this? Hold on, let it focus. You have to give him a second. Hold on, I'll try again. I just pushed the focus button. Hold on, here. Okay, so I showed this to you already. Sine at 30 degrees is 1/2. Sine at 45 degrees is square root of 2 over 2. Sine at 60 degrees is square root of 3 over 2. then cosine at all 3 degrees, tangent at all 3 degrees. They also give you on this page cosecant, secant, and cotangent. But if you know these 3, you have to have these memorized. That's what those ordered pairs are on that unit circle. These are going to help you do the next thing where they're going to say, hey, can you find sine at 540 degrees? Well, that's ridiculous. Well, if you figure out what its reference angle is, you're like, oh, 540 is really just sine at 30. Well, what's sine at 30? It's 1/2. Done. So you have to find the reference angle to then know these numbers. And no, you can't just use your calculator, because does your calculator give you those weird square root answers? No, it does not. So that guy right there, he is in your book. He is on page 614. I did already give you the notes on this, and write this down, right? On 9.2. So it is in your notes already if you actually did take notes. You do need to know this. This is page 614. 614. Because we are going to do an example or two right now. But it is important. Okay. Where is marker? So if I leave this and give you this, we have this problem. It says find the exact answer. That means we need to actually know this. So find the reference angle. You want to know the angle between 0 and 90 for this every single time. Okay, so that means you want to find the reference angle. So 240, what's it closest to? It's closest to 180. Is it greater than 180 or less than 180? It's greater than. So 240 less than 1 minus 180, because it's greater than. What is that? 60. That means we need to know what is cosine at 60 degrees. It is 1/2. Well, they expected you to be wrong, that they didn't even think that you'd be right. Maybe you said it, I don't know, did you say it in a questioning way? I knew you were right, but I was 1/2. So that is how you do one of those problems. Where's my towel? I don't know. No. Though you could have, let me do this. Let me start off easy. Cosecant at 30 degrees. I made it easy for you. This is the easier version. So you need to know that cosecant is the inverse of whom? Okay, so you need to ask yourself, what is sine at 30 degrees? So the answer is 2. So if you're ever given cosecant, secant, or cotangent, switch them to the main 3 first, find that answer, and then just go backwards, okay? And just flip it. Okay, those are just degree ones. So the degree ones are not that bad. Okay, we're gonna do a radian one. Okay. We'll start with an easy one. Tangent at 5 pi over 6. Yeah, that's what I have. Now, the cool thing about the radians is they are a dead giveaway of which ones they are, because the denominator tells you which one they are. So your reference angle is tangent for pi over 6 because it's whatever the denominator is. Okay, well, which degree has over 6? Yeah. We don't care about the 5 pi over 6. Just think about 30 degrees. So now we need to know what tangent is at 30 degrees. Did you just say that because you thought it would be right? It's not. Tangent doesn't have halves. It has mostly 3 numbers. It is the square root of 3 over 3. Where did I put my thing? So with radians, this is what I do. I'm not gonna lie to you. This is what I do. It's always one, like it's always pi over a number. So it's pi over whatever this number is. Yes. A little backtrack. This guy right here. I need an actual pencil. I had one. Okay. These guys, you see how you have all these points? You know how like normally this is X and Y? Yeah. A little hint, because we're going to be doing this later, because you could use this to study to memorize these things also. It goes cosine, comma, sine. It's alphabetical. That's how I remember it. And then your tangent answer, people always just write it on the outside. So all you would have to do is write it in the first quadrant, because reference angles, right, are always between 0 and 90, because they're always acute angles. Okay? They are always the same. The only thing that will be different is, you know how this is how the first quadrant is positives? Well, what's different about the second quadrant? Negative, then positive. That means the x values will be negative. That's literally the only difference. The numbers will always be the same, but they'll switch to be negative. And then down here, right, they're both negative. And then over here, you got positive, negative. That's the only difference. These ordered paired numbers never change, which is why this works with every reference angle ever. So it doesn't really matter that this was 5, 6. All I care about is what the denominator was, because that'll help me figure out what degree it was. Okay, so every single time you can do that. And luckily, none of you, except for Aubrey. Aubrey's the only one who'll miss class tomorrow, because you got that English test. I'm sorry. I feel for you. But we will make sure you're paying attention to this, because what we're going to do tomorrow does build off that. We're going to use more of the unit circle. And then if you would like extra copies of the unit circle for practice on your own, you can always just ask me for them. I have extra. Jason can attest to it. I had extra in here now. And then I'll give you a blank one. I'll time you. It'll be flipped over like this. It'll be flipped over like this. And then I'll say go. And you just write your name on the back, so you don't have to waste any of your seconds writing your name. It is like a minute to win it. It really is. Okay. Does that make sense?